Good morning and welcome everyone to DISYS' December webinar, AWS CloudFormation with Chef, adding a new dimension to agility. I'm pleased to be joined by Naveen Vijayakumar, an AWS Solutions Architect with over 4 years of AWS system integration experience. Naveen is also skilled in other cloud platforms, including Azure and Office 365. Before we get going with Naveen, I'd just like to say if you have any questions throughout the webinar, we will be conducting a Q&A at the end of the session. Just include the slide or topic and the question that you have in the question box on the GoToMeeting interface, and we'll address that at the end. Naveen, if you want to get started, go ahead.
Thank you, Brian. Good morning, good afternoon, good evening, depending on the time zones here. I am Naveen. I've been working with AWS and CloudFormation and other platforms for a couple of times, and trying to incorporate the existing on-prem data center to migrations to cloud and trying to architect for scalability, elasticity, and best performance for cost. And so today's topic in our hand is AWS CloudFormation with Chef. The high-level agenda is to kind of cover ground with what exactly CloudFormation is all about and what is Chef, and kind of going next step to find really what exactly would be the real value add when we combine those together. So once we cover that, we would like to also show our proprietary cloud enabler and accelerator. So without any further ado, let's take it. So to start with cloud computing, with increasingly number of enterprises, with increasing number of companies pushing towards innovation to find newer ways to newer ways to make real use of cloud computing, leveraging the ways in which existing infrastructures can be migrated to cloud for cost, compliance, high availability, scalability, security. Cloud is no more a buzzword, and it becomes the new norm. And there are a lot of studies indicate that cloud adoption is kind of in an accelerated phase, and it is indeed one of the good times for the cloud computing to be at the start of this era. And the important thing here is to understand that with elasticity in place, we always try towards faster go-to-market, aligning the existing computing needs, or more appropriately business needs, to the computation needs, vice versa. That is, as the business grows, we have the ability or the capability to push forward the computation needs and kind of bring down the excess capacity when we don't require. And the ultimate bottom line is to move the huge capital expenditure, how it was for several decades of computation infrastructures, and to make that capex to opex. So which means that we do not need any upfront commitment or an agreement to sign up for a long-term association with the cloud vendor or the on-prem data center, which not only brings computation but also overhead like cooling, administration, real estate, electricity, and burden to the existing key business. So concentrating on all the above factors, so this is like every single attribute adding to the overhead, we are kind of deviating towards or not fully concentrating on the core business. So for any enterprise or for any organization, be it the real advantage or the real push towards the drive to the innovation comes when they concentrate more and more on their core business rather than helping or rather than running servers and managing servers. So this is the bottom line of cloud computing, and let's look at Amazon Web Services. So Amazon Web Services started with the vision of making everything as a web service. So be it a virtual machine, be it a data warehouse, be it a database, or be it a flat file storage system which can handle few kilobytes of data to all the way to few terabytes of data. Everything can be provisioned anytime and can be deprovisioned anytime. You only pay for exactly the amount of time the particular resource is being used. More appropriately, we do not pay as we go. We only pay as we need. So you run a particular piece of instance for 3 days, you exactly pay for 3 days. Be it 3 days or 3 hours, you exactly pay for 3 hours. No more questions asked while kind of terminating the instance, or no questions asked while we request for more instances. This is indeed the crux of the cloud computing, and Amazon Web Services brought in the innovation, the economies of scale, and everything put together and started offering as cloud provision. And moving on, cloud is being in very extensive landscape covering all the three or main phases of main variants of cloud computing, as in SaaS, PaaS, IaaS, software as a service, platform as a service, and infrastructure as a service. AWS started with purely with an IaaS perspective and kind of diversified into other cloud variants with cheaper cost, new capabilities, new set of services, and the scale, the spread across the geographies. So Amazon touches every single aspect of what an enterprise or a startup requires for them to grow continuously, be it analytics, application services, deployment, and devices. Concentrating on the core business or the core idea and core innovation is indeed their fundamental ideology, and AWS does play by their rules. So taking a moment here to understand Gartner's Magic Quadrant, and in the recent surveys, Gartner estimates that Amazon Web Service has 5 times the compute capacity than all of the 14 other vendors as analyzed in the report combined. So this is indeed an indicator that the scale in which Amazon is operating is massive, and AWS is known for continuous innovation. And considering the two items of scale and the continuous innovation, Amazon indeed passes back the advantage to their customers. So one of the examples or one of the ways in which we could illustrate this particular point is there were 40+ price reductions right away from the materialization of AWS way back in 2006. And the recent price reduction being just 4 days ago, which was with respect to network bandwidth and CloudFront in CDN's perspective. So assurance is a good, these are the key indicators or key metrics which is more like an assurance factor for a good cloud platform. Today, a few of the services in the platforms of IaaS PaaS, obviously we do have Elastic Compute Cloud, relational database service in the IaaS perspective, Elastic Beanstalk, and with the latest introduction of container services in the PaaS landscape, and Zocalo, Amazon Zocalo, and Amazon Workspaces in the SaaS perspective. And while having a corporate Active Directory or having a directory service indeed is becoming more and more crucial, more and more critical, and more overhead, Amazon did bring directory services, and which is indeed the first step to going deep into the landscape of enterprise needs and enterprise key problems. So indeed, so with a wide bunch of services which is being run as a service where any organization or any individual can sign in, use, and terminate anytime, gives infinite number of combinations in which they could just use with a single credit card. So let's start with the basic building blocks of AWS service. So fundamental thing is Elastic Compute Cloud. So this is more like a virtual machine offering from AWS, and there are several varieties of platforms like Windows, Linux, CentOS, OpenSUSE available right out of the box, and we can go and keep building on the existing platforms given. So we can take a plain Windows instance, and install SQL Server, it becomes a database instance, or modify the overall setup and configuration to closely align our existing as per our requirement. And with platforms in one of the angles, and there are yet another sizes, instance sizes, all the way from micro, small, large, extra large, 8x large, 4x large, etc. And there are also specialist various types of instances being tailor-made. So we have general purpose instances for general workloads or non-crucial workloads, and we do have option to run IO-intensive workloads, memory-intensive workloads, GPU, that is graphics processing workloads, and there are G-based, that is G-series instances for GPU-based instances, I-series for high level of throughput in IO and IO-based instances, higher memory instances, higher processing instances to closely align or mix and match the AWS instances to get best use of our existing application. So moving on to Amazon Mission Image, AMI, more likely like EC2's heart and soul is an AMI. That's the way we could kind of put it. And or to extrapolate, or more appropriately, the behavior of an EC2 instance is highly determined by the AMI, apart from the capacity aspects like instance size, ECU, virtualization type, etc. What goes inside an EC2 instance is fundamentally an AMI. That's the base image or the templated aspect of an instance altogether. And these AMIs can be either public, private, shared, meaning we can come up with a best configured or optimal configuration LAMP stack and create an AMI and make it available for the entire community to make use of that without going through the pain of configuring the same AMI instance again, or kind of share it with a particular AWS account, more like our organization and our sister concern organizations are more like a trusted third party. So this way, and we do have something called as AWS Marketplace, where popular vendors like CentOS, Ubuntu, and other companies who can custom create, bake their own AMIs and give it for the AWS user to start using it right away. We have Adobe CMS instances, we have WordPress instances, Drupal instances. So assuming when we need to set up an WordPress, all that we need to do is pick that AMI, launch an EC2 instance, and we have a fully functional, full-blown version of a WordPress already being configured. This is just an example, but there are a whole bunch of marketplace items listed into this. And every AMI is bound to a region. So going back one step behind, a region stands for a geographic location, and there are nearly around 9 geographic regions present, 3 in USA, 1 in South America, 2 in Europe, the latest being Frankfurt, etc. It is wide across the global footprint for to cater the needs of the local people for latency, jurisdiction or compliance needs, etc. And next is VPC. More like this is the networking brain or the networking of the entire AWS together. And it all started with an add-on to an existing set of services. And it kind of, with the power and the flexibility of VPC, AWS continuously tries to make this as more and more ubiquitous. And it is indeed, it makes sense because it really helps AWS customers to make best use of VPC for security, flexibility, enhanced set of features, and more the window of opportunity to link our on-prem data center or on-prem servers to cloud instances, or more likely like AWS, can be done even more easier. So with VPC, we can kind of come up with we can kind of visualize the entire AWS as our own data center and set up our own subnets, IP ranges, DMZs, DHCP configurations, assign a particular IP for a particular instance, and set an IP range for a set of instances, which we would be able to do only if we are running those instances in on-prem. But having the same capability to do it in the cloud instances is something which a virtual private cloud exactly does that. So we had discussed about regions. We have something called as AZs, which is called as availability zones. And AZs are more like a sub-data center, and every region has at least 2 AZs. And the important thing about an AZ is that AZs by themselves they don't share any essential data center resources like cooling, network, and power, and which means that when you kind of spread your instances or spread your application across AZs, so that's the first step or the easiest step to make your existing application HA easy. And speaking about EBS and snapshot volumes, EBS volumes would kind of translate to drives of our instances, servers, and snapshot more appropriately would be the point in time kind of a point in time captured data volume. So speaking about snapshot and volumes, so we could kind of pick this analogy. In a couple of decades ago, we had the concept of photographs and photographs being developed from a negative image. So the negative image can be assumed to be a snapshot, and photograph can be imagined as a volume. And the analogy stops here. Stops at the point where the limitation here is with EBS volumes and snapshot, we'll be able to create a snapshot out of a volume as well. Rather, the capability of creating a negative image from a photograph is something not possible. So that's where the analogy stops. So what it means is that, so we can kind of have a volume, do add necessary files, do set up configurations, assume it to be a drive which is attached to our local system, do whatever we want, or to have our own file structure, file system, and make a snapshot out of that and create as many volumes as we want. And these volumes can be moved across regions, across AZs to cater our application needs. So you can create an existing volume in North Virginia region, have all the necessary configurations and customizations done, take a snapshot and move the snapshot back to Singapore, and then create a volume out of that and attach to a server there, and we have a full-blown version of the copy of the drive, what it was in Virginia, and back to Singapore with very, very minimal effort. So that's with the necessary basics about AWS. And here let's take a sample architecture, more like a LAMP stack here. So this is a simple HA architecture. That's what how we could put. And we have two availability zones. That is, we have two VPC subnets, one in the availability zone A and one in availability zone B. And we have a database instance in one of the subnets. So we do have two web servers, and which are being kind of linked with an elastic load balancing. So which elastic load balancing act like a load balancer. And when there is an internal traffic, ELB, that is the elastic load balancer, can be configured in a particular way to kind of distribute traffic evenly, or based on an algorithm, based on session, based on latency, based on the capacity that is more likely like the load of a web server, etc. So those are all the configurations which can be done here. And these web servers talk to a database instance behind it. So this can be straightforward, assumed to be in Joomla, assumed to be in Drupal, or WordPress, etc. The points to discuss here is we have an VPC. So let's take a break here and understand what are all the AWS resources specified in here. We do have a VPC. That's the first step. And followed by VPC, we have a VPC network altogether. We have a web subnet. We have a database subnet, and we have elastic load balancing. And getting back to the subnet, every subnet would have a root table. And if it is a web subnet, that is when the particular instances which, when placed in a web subnet, would require an internet connectivity, then it requires an internet gateway, and followed by security groups. So one for the web server, one for the database, and the other one for elastic load balancing. We do have, now we would go ahead and create web servers, one in either of the availability zones, and followed by database instances. So there are nearly around 12 different items to be created, configured, set up in a particular way to achieve our own resource. And there are several ways in which we can achieve the same thing in AWS. One is with AWS Management Console, followed by AWS CLI, and we have a whole bunch of SDKs to achieve this. So AWS Management Console is the web interface to create the AWS resources. All that we need to do is log into aws.amazon.com/console. You log in with our credentials, and create an S3 bucket or an EC2 instance, stop an EC2 instance, launch an EC2 instance. Everything can be done right from the AWS Management Console from any of the latest supported popular web browsers. Not only browsers, we do have iPad, Android apps, and other interfaces, other mobile devices access as well. That's with the Management Console. And next we have CLI. CLI is more like a command level interface, and which when installed in a particular operating system of either Windows or Linux-based operating systems or Mac systems, we can kind of integrate that with the existing set of crons, scripts, batch files corresponding to the operating systems, and can treat AWS as a platform, not like an extension platform. Rather, creating a new file and creating a new EC2 instance would be just a single line of code or single script. So that's with the CLI, and we have support for making use of higher level languages like Java, JavaScript, Python, .NET based things, and which means that if a .NET based developer who is well versed with C#.NET doesn't need to worry about intricacies of creating more like creating a wrappers for REST interface or SOAP interface and kind of parsing the XML and making use of the XML to interpret what exactly was done, and rather straightforward. All that the developer needs to do is install the SDK and make use of his existing expertise of .NET and go ahead, create, modify, delete, launch, relaunch the AWS resources as per his or her need. So this is with the various ways in which we could create the LAMP stack, which we saw just here. And there is one fundamental problem or the difficulty here is that it could be really nice and exciting to do it for the first time, second time, but third time it kind of goes on, pulls down the excitement of the real work which we did. The ultimate reason behind AWS is to, or the ultimate goal wouldn't be just to create an instance. The real thing would be to make use of that instance to do a piece of work or do a business operation. That's the whole idea into it. And we just saw that there are 12 different things to achieve, or the goal of these 12 combined will be in LAMP stack. And once this LAMP stack is being set up, we can go ahead and create WordPress for us to set up our own corporate blogs here. And with cloud, we can kind of start the instance, stop the instance anytime. And assuming when we kind of try to do this on and on again, and logging into Management Console, clicking the bunch of buttons, configuring the security groups, configuring the network ACLs, enabling internet gateway, setting up VPCs could kind of become cumbersome. And the important thing is the ownership, the responsibility, the maintainability kind of becomes elusive. And so that's exactly where AWS CloudFormation comes in. So until now, we were kind of looking at our applications code, our enterprise application, enterprise business application to be in a code, or we write a code to kind of build applications. How about a way in which we have a templated language or templated domain-specific language where we could in a particular way determine and define AWS resources. Just like we have EC2, we have a particular JSON which can be written in a particular way to define EC2 instances which can handle and accommodate necessary configurations and create a script out of that. So we use CloudFormation uses text-based, JSON-based, that is JavaScript object notation, and given that it is a text file, it is a flat file, all that we need is either a Notepad or a Notepad++ to do a full-blown AWS stack, which involves auto-scaling, which involves high availability, which involves a whole bunch of AWS resources. So everything can be dictated by a single text file. So in this case, it is a JSON-based file. And important thing about CloudFormation is CloudFormation as it is doesn't isn't charged. It comes free of charge, and we do not pay any specific amount of money for CloudFormation, but rather we would be paying money only for the the resources which the CloudFormation would go and materialize. More likely, like if you write a CloudFormation script to create 10 instances, you will pay for 10 instances, and the CloudFormation doesn't get charged or comes with the cost. And so taking a deeper dive into CloudFormation, when you kind of visualize a particular stack, until now we would be visualizing a stack into a couple of diagrams and architecture diagrams. And if you were able to write a JSON file to kind of define the existing stack or your desired stack, so that is CloudFormation here. And so to touch upon the key benefits, it offloads all the heavy lifting of the CFN. So we kind of just saw that what would it take to create a LAMP stack, and rather you would just write the CloudFormation script once, and you can run this CloudFormation script n number of times in the same region, in a different region, in the same AWS account, in a different AWS account. It doesn't matter anything. So just go, click, and you have the entire stack which would be created by the CloudFormation. And given that this is a text-based thing, it can neatly go inside your version control, your corporate version control. More about this shortly. So we would look into this about infrastructure as a code. We would have a deeper discussion on this shortly. And important things about CloudFormation use cases. So Hadoop, setting up a Hadoop cluster is a very, very big, very extensive, sophisticated setup by its own, and it may take days, if not weeks, for us to configure a fully functional Hadoop. And when we kind of try to do this on and on again, this by itself is a task, and kind of making use of Hadoop to have analytics about our existing data would come later. So this kind of stops or makes the first hurdle in taking up or letting us to do what we really desire. And if you have CloudFormation, you have a file, just push that file across, and you have a full-blown Hadoop Hadoop setup created for you in minutes time. And same thing with AWS test drives. Test drives is more likely like it's literally a test drive where enterprises can create a CloudFormation template and give it for their existing customers or new customers or prospects to have a look, to get the feel of what exactly their application be. And most likely the test drives would be a subset or a scaled down version of their real full application. And these test drives are given to users after taking a couple of questions from their client, and their clients can have the ability to test the entire stack without paying anything, nor like explicitly or forcefully required to key in a credential data or an AWS account. So these AWS test drives kind of separates all those problems or sorts out all those problems. And if a lot of companies kind of come up or offer their existing solution in a SaaS-based model, so in which every new customer who can be materialized or can be fully onboarded by creating or executing a CloudFormation template with configurations pertaining to that customer. So customer A can be keying in with customer A with attribute A with detailed configurations of A would have necessary information about A, and customer B would be having a whole set of different values, and keying in those values to CloudFormation template would create a new stack which can be consumed right away. So that's with a few of the use cases. And so here, this is how a sample EC2 template would look like. This doesn't have all the parameters or attributes for an EC2 instance. Few of the attributes are mandatory, few aren't, and there are a couple of attributes which, when changed, doesn't require a reboot or termination of the existing EC2 instance and creating a new one. So, for example, instance size like instance type like m1.micro or t1.micro. Currently, when you make use of the existing template and launch a new instance with t1.micro, and when you want to change it to m1.small, you would just require to change this t1.micro to m1.small and send across the same template to AWS, and AWS would look at the existing setup and kind of take a look at the newer setup of the newer version of template and do a delta and does and changes appropriately. So here in this case, changing of an instance type from t1.micro to m1.small would indeed require to be scrapped off the older instance and put in place the newer one. Whereas things like tags would indicate like the name of the instance, the cost center, the department, all those things doesn't require replacement of the instance. It could straightforward go and apply or do the changes. So here our interest is image ID. Image ID stands for the AMI ID, and every EC2 instance behavior is first determined by the AMI. More likely, like just like humans have a DNA, and every EC2 instance would have an AMI ID, and that's from which the entire EC2 instance gets materialized. So, taking a moment to discuss about AMIs. AMIs are region specific, and creation of an AMI by itself is time consuming, as you would like to create a base AMI, and for making use of an AMI, you would create an EC2 instance and do configuration, and then bake that AMI and do it. So there is a certain amount of time, and there is an effort involved in creating that AMI to match your need. And it is as and when your application kind of evolves to newer features and newer function set and newer patches, creating or recreating AMIs every time is a very, very time consuming and effort intensive process as well. And you have an existing AMI at one region, and taking the same AMI and putting back to a different region like Sydney would literally mean that you would be picking up few hundreds of GBs and pushing it to a newer region across the wire. That is literally, you would move hundreds of GBs over the public internet. And when you kind of would like to have all the AMIs in sync across all the regions for higher availability or disaster recovery, this would become a huge bottleneck for you to go faster, for you to kind of determine a faster time to market. And golden AMI. So this is the more like an enterprise term of treating an AMI as a golden AMI, meaning when you do all the necessary things and mark it as final, the then final, or the notion of final at this point in time would be called as golden AMI. And there are a lot of information. I mean, we have more information about this coming up shortly. And let's switch gear now and take a moment to understand what is Chef here. So Chef also turns infrastructure into code just like CloudFormation, except that CloudFormation would operate at AWS level and Chef can operate inside an instance level. Chef by itself is created using Ruby and Erlang based configuration, and uses terminologies of both IT as well as in cookery, chef based kind of things. We have terminologies like node, service, workspace, etc., with also terminologies like recipe, cookbook, knife, etc. So the intention of this webinar isn't to go deeper into the Chef, rather kind of understand the value add Chef really helps us in. And one information which we would like to underline, bold, italicize is that the idea of combining CloudFormation with Chef is equivalently powerful, equivalently meaningful, equivalently easy when we kind of consider it with other popular cloud configuration management tools like Puppet, CF Engine, etc. So it's more likely like at this point in time we can just take Chef as a placeholder for configuration management tools and have the discussion ahead. So this is about Chef architecture. We have AWS Amazon Web Services here. This could be either one instance or 5 instances or 10 instances altogether, and each and the information, the metadata, the data, the configurations, the state, the information about all these instances is stored in a Chef server, Chef server would keep track of all the instances, their metadata, their existing state, and there should be an administrator workstation where that would be the central portal to kind of orchestrate all the AWS instances or the all the instances which are being controlled under Chef. Excuse me. So we have Chef variants like either the Chef server by itself can be a SaaS-based thing, which means that you don't need to undergo the pain of creating, configuring a Chef instance by itself for it to make use, and rather you would just require to sign up to the Chef site, and they give an endpoint and credential for you to get started immediately without need to worry about the HA, the scalability of this particular part of Chef server. And there is an on-prem model, and there are its own pricing intricacies, the feature set to align or closely align to your end state. So here we kind of come back and compare or kind of mix CloudFormation with Chef. So both both turn infrastructure to code, one with AWS resources and other with the configuration which goes inside the instance, and both empower the DevOps. And this kind of is something new or new to this combination altogether, is you can version control everything, not just the application, not just something which goes inside your server, but you can version control the state of the server, the process of creating the server, everything can come from the corporate version control or a Git. And so all that you need to do to make use of the following possibilities, to discuss about the following possibilities, would just you require to bootstrap the code in every single instance being used, and once that instance, the newly created instance is created, the bootstrap code would kind of get self-installed in the instances and would go talk to the Chef servers here. So that would be the necessary configuration, ideally speaking, that would be the necessary configuration for you to get started with CloudFormation and Chef altogether. So here we take, so we come to the real, the reality of the real power of combining Chef with CloudFormation. There is, the first one would be to multi-dimension automation. So every time when you write a code or every time when you kind of try to code something to solve a piece of work, which means that there is a scope or there is a margin, there is an option to automate either using crons or schedulers or whatever which is applicable in the enterprise. So now, until now, we would be writing a code to process a database entry, and from now on, we could process an AWS resource as well. So enforcing the automation to the overall process ensured more planned delivery, and with CloudFormation and Chef reduces the need for ad hoc provisioning and modifications, both at the outer aspect of that, the outer peripheral of the AWS infrastructure as well, and what goes inside the AWS instance as well. So that's with the first possibility. And second thing with that, the dev and DevOps problem. So we have the problem of either I'm a dev, I'm an ops, or there is a dev in my code, there is dev in my ops, and there is ops in my dev. So all these things. So this is indeed a very good possibility or a very good starting place for us to empower DevOps, and thereby expanding the horizon of cloud adoption and empowering even more DevOps to take in charge or take in charge of the entire aspect of cloud as an extension to the existing on-prem data center. So CloudFormation and Chef. So with CloudFormation and Chef, you would now just wouldn't stop just at setting up the infrastructure or managing the infrastructure. So doing both was kind of not possible until now. So CloudFormation, we have seen that illustratively that it kind of sets up your entire AWS resources as per your need. But with Chef, what exactly Chef does is, so the Chef would keep track of the existing state of the instance, the end state of the instance, more likely the desired state of instance, which is determined by recipes and cookbook which we write. so the recipe in cookbook can be can be defined to create a web server out of that instance, or an app server out of that instance, or to kind of pull in the existing code from the existing version control system and install it, and then create a system out of that. And the important thing with the Chef's recipe is that these recipes can be executed across single instance, 10 instances, 100 instances, or thousands of instances. The reality here is either manage one instance or 10 instances, everything would become a magnitude of 1. So that's indeed the real power of Chef here, or by extension, configuration management tools. So it was very hard to manage the infrastructure after the CloudFormation was used, or it was rather a very a very long journey for organizations to use Chef without CloudFormation. So when you combine CloudFormation and Chef, you would those are all the necessary things for you to keep the entire show running for the enterprises. So we can kind of pick one of the analogies like flight analogy. Like CloudFormation would create the necessary aircraft in place, and Chef would kind of put the necessary ground staff and cabin crew for you to take off, for you to have a takeoff. So that's the way in which we could kind of understand this. And free from the clutches of golden AMI. We have seen that AMIs, golden AMIs, it's merely the way you would like to kind of call it. All AMIs aren't golden AMIs, and every golden AMI is an AMI. So more likely, like the latest or the most desired required AMI would be termed as a golden AMI. So AMIs are by themselves bulky, bigger, slower, and so going back to yet another analogy is that it's like a unicellular organism. So we have seen that evolution kind of organisms which are more intelligent. Now we had the problem of keeping sync of existing code and having so that's why version control systems are there in place, and kind of taking a pass there and making or having the need to keep in sync of AMIs across all the departments, across all the regions, would by itself require a whole bunch of DevOps team to take care of that. And to reiterate the point again, version control the entire enterprise. So we the entire application which would run in cloud, both the infrastructure as well as the application, which when can be taken from an corporate on-prem source control system, can create instances, create applications across all the cloud platforms, across all the AWS regions, either in North Virginia or Sydney. All those things become just a configuration changes or a single line of code of change to do the necessary things. And faster releases. So although if as and when if there is a new feature which is being tested and ready to be released today, we do not need to kind of queue in for the release cycle and wait for the release period for it to go to the production. Rather, as and when, realistically speaking, if there is a tested, hardened release ready for shipment, that can ship right away, and that is the state, that is the sophistication of automation which can be achieved when we kind of combine CloudFormation with Chef and test drives. So more like a corollary to the earlier point. So when we have smaller, quicker releases, it is easier to backtrack if there is any problem, and it is always easy to take smaller steps and get back smaller steps rather than to leapfrog and go back to an unknown state or to a safe earlier state. Experimentation is indeed the key for innovation, and kind of experimenting frequently does kind of encourage innovation in a lot of aspects. So testing out a smaller footprint and making it available or releasing it to the wild and backtracking if and when required. So that's something which is not possible when you kind of directly use CloudFormation with AMI altogether and on-premise to AWS migration. So here there are two ways or three states in which we can be assuming. Either an existing organization making use of CloudFormation alone, an existing organization which is making use of Chef alone, or existing organization which doesn't go to, hasn't any cloud practice altogether. So with CloudFormation, with existing organizations which is making use of CloudFormation, when coupled with CFN, we get the best of both the worlds. And if an existing customer making use of Chef alone, and it would be a good point for them to take a break, get back to the whiteboard, do the necessary steps and configuration, and kind of release the newly created CloudFormation to get them to speed, to couple CloudFormation with Chef to have their operations in a performed in a smoother way. And when an existing organization which is looking at the cloud migration to the cloud, so this would be a very good step for them to create CloudFormation followed by Chef practice, and with exactly 2 clicks, one for the CloudFormation and another for the Chef, the bootstrap Chef process, and their existing data center can fully be moved to AWS in, realistically speaking, or possibility of in just 2 clicks. And more likely, like the corollary of this point would also mean that the adoption of all-in strategy, which AWS is continuously trying to AWS, which is increasingly getting popular these days, and instance avatars. So the core behavior of the instance, the easy to instance, was determined by an AMI. So with this, with fewer changes or the additional recipes, an existing web server, which is today, can also become an app server on weekends. So simply, there can be a schedule which kind of pushes up newer recipes, which would kind of dictate the instance to be an app server. So this is the way with these kind of practice and these kind of ideas. So these are the ways in which we would these are the ways in which we can push the limits, the opportunity to innovate and experiment, and this definitely kind of improves the overall instance utilization. So we don't have that much of traffic on weekends, and to optimize cost and to improve utilization as well. So these kind of experiments would indeed help innovations to newer heights. And the important thing here about is newer, easier, faster disaster recovery. So assuming there is a catastrophic event at a particular region where the entire region goes on inaccessible. So during this state, so making use of the corporate source control systems, the same code which was running until now for region A, the same code can be pushed to region B, and the latest both infrastructure as well as code, the application code, can be pushed to the newer region and the new region, and your entire application can go on live immediately. So it would be more like just switching off the domain. So until now, corpa.com would be pointing to servers in North Virginia, and now that with the CloudFormation script followed by the Chef script being executed in the newer region, it would be merely change of a domain name from domain IP address from earlier region to the new region, and everything can go as latest as possible. And having or like managing the latest AMS from or more likely like pushing the golden AMS from one region to other region continuously would be costlier, would be time consuming, and a huge overhead. Rather, adopting to these kind of things would require zero dependency on AMS or that kind of a practice. So we are sure that AWS does provide base AMS like Windows or CentOS or Red Hat, and all the other things, all the other application needs like IP tables, databases, configurations, patches, can be dictated from the Chef or the configuration management tools. So this means that we do not need to keep track of the AMIs for its patches for security vulnerabilities, latest updates, or more likely like application updates, newer features doesn't need to go into AMI. So we can be free from the clutches of the AMI, and the behavior doesn't depend on the AMI by itself. And so this is pretty much what we would like to kind of have the combinations, the real, the power, the real innovations. These combinations are endless, and there can be newer kind of things which can be definitely tried out here. So these are the key points here, and at this time we would like to take a kind of a summary in which we have seen that CloudFormation can be used to, can be visualized to in a way like it can create an aircraft, and aircraft doesn't fly by itself. It requires necessary ground staff and cabin crew for its smooth operations. So Chef comes in. So with creation of an aircraft and the necessary ground staff, so you would require, that's sufficiently enough for you to run the entire show of airline business. So in an analogy perspective. So similarly, CloudFormation and Chef would definitely help automate, expand the automation, and empower DevOps in a broad perspective. So as discussed, so we are towards the end of the webinar here. So we would like to discuss about, show what is Zero and what are its capabilities. So at the high level, Zero is a cloud-enabled tool, or more appropriately, the cloud accelerator. It is fully built, and the key foundations are from Amazon. The Zero, the Amazon Cloud Accelerator by itself, is running on Amazon to leverage the security, leverage the elasticity, the availability, etc. And it is built purely in a simple dashboard, intuitive controls, and supports major processing and analytics applications. So let's directly see a Zero in action. So when we log into Zero now, so here we would see the list of live resources which are being created here. This gives us the single dashboard, unified way of list number of instances, number of volumes, IPs, key paths, and the key or critical AWS infrastructure is running, followed by how the consumption of the stack is being created. And obviously we see that November was the costliest month, and so we would kind of have complete information about the cost per stack and spread across for the month, and etc. We would look into what is stack here. So Zero, a tool by itself, comes along with a stack library, which is more appropriate or relevant to the applications, more likely relevant to the enterprise. There can be n number of stack templates which can be loaded into Zero and be launched, configured and launched here. So assuming and corporation A has nearly around 10 different applications running, there can be nearly around 20, there can be 20 CloudFormation stacks here. So 10 for the staging and 10 for the production here, production use. So assuming a LAMP stack here is one of the templates here, all that we require for the LAMP stack to be running is to fill in these details, and followed by completing this wizard, we have a full-blown CloudFormation being materialized with a couple of clicks. And important thing is about the repeatability. So that's with one of the aspects of stack templates, more likely like a stack library, and followed by the stack console. So once, as and when the stack library is being created, the CloudFormation template is materialized, we have a control to understand how they are created, what are the resources involved into the and any instance can be started pertaining to that stack here. So Zero doesn't doesn't only support CloudFormation as it is. So there is a way or a interface to manage additional other AWS resources like servers, volumes, security groups, elastic IPs, AMIs, snapshots, ELBs, etc. So this indicates that you could your cloud operations team can be given access to Zero and thereby decoupling to the existing AWS resources, or the need to configure AWS IAM user for everybody or every single user. So there can be a subset of operations or every DevOps or a particular DevOps wouldn't require open access for all the AWS operations, and rather to control what operation or what stack that DevOps is responsible can be neatly aligned, and fine-grained control can be established with Zero. And Zero also comes along with a whole bunch of reports like activity logs. Activity logs pertains to who logged into the Zero tool at when and what time, and every single action is being tracked here, which is important and mandatory for several of the compliance policies. And we do get the detailed report of the detailed breakup of all the AWS infrastructure and resources. So not at the instance level, but also at the snapshot, usage, IP, the out bandwidth, and other costs fully pertaining to the fully itemized way. We do have the ability to get the reports or the complete picture of everything which is running in your AWS in a neat, concise report way. So followed by the CloudTrail. So CloudTrail is which was launched roughly a year ago, kind of keeps track of all the AWS calls which are being made. So AWS by itself is a web service, and here we would the CloudTrail service, which comes out of the box, or more likely like straightforward service from Amazon, keeps track of all the calls which are being made here. So in this case, so those logs aren't readily consumable or not readily human. Doesn't directly pertain or make any sense to humans. So we require certain level of extraction, transformation, and loading, and kind of we need to consolidate in a particular way for us to understand which event kind of was the maximum concentrated events like, and from which IP address the overall calls were being made, and which of these users were being done by which user performed the maximum thing. These are all the necessary reports which are being extracted from the CloudTrail, and we do have comprehensive listing, sorting, and rolling up features. And next is CMDB, of Configuration Management Database. So this keeps tracks of all the changes which is being done to the AWS resources. So let's assume we attached newer volumes to the existing EC2 instance. When the instance is being started, when the instance is terminated, when it was stopped, who has done it, from where it was done. So this CMDB kind of continuously logs in, keeps track of all that information for several of the audit purpose. And we do have the process to download these reports put together. So these are the key, or more likely like the highlights of Zero feature set altogether as it is. And so Zero by itself is a platform, is continuously evolving with newer features being added to the Zero's capabilities. And we do have newer releases of AWS services altogether, which makes room for, which is an opportunity to Zero for us, for Zero as well, to continuously make a real value add for cloud operations to the enterprises. There are several customizations or premium kind of setup which is being done in Zero, which helps organizations to automate or kind of really empowers the enterprise to manage their cloud operations. So there were a couple of customizations like scheduling a particular stack to be launched at a particular time and stopping the overall stack at a particular time by making use of spot instances for cost advantage, and enhance the set of That's it from my side. Over to you, Brian.
Thanks, Naveen. I just have a couple questions that came in here throughout the duration of the webinar. The first one in reference to Zero toward the end. Do you have a stack template for QA and load testing?
Absolutely. So the capability or the functionality of the CloudFormation template is the way like we can create whatever we want, or we can achieve whatever we want by making use of a template. We can certainly kind of sit together, understand the dev and QA, and make it as a CloudFormation template and run it. It would certainly be possible.
Okay, thank you. A couple more questions here have rolled in. Do you have a timeline of setting up a CloudFormation with Chef?
Yes. There were a couple of out-of-the-box templates which Amazon themselves are giving, which is available straight away from Amazon's template library, but we are really not sure about what are the capabilities or which version of Chef it has been using and how it has been configured. So if you kind of look into the AWS documentation, we do have quite a few templates which is pertaining to Puppet, Chef, and other configuration management tools.
Okay, and this leads into kind of the next one. How does version control affect the cost and timeline of the setup?
It would more like, so it all depends on what exactly we try to do with the CloudFormation template. So today there would be 10 instances which would be dictated from the CloudFormation template, and rather than going into AWS management consoles or having a DevOps perform those operations, so all that you need to do is remove those 10 instances from the stack, which would also be logged into the version control, and all that you need to do is push that file to CloudFormation, and all those 10 instances would be removed as soon as possible. So faster termination of the instance means faster you are stopping the billing meter. So that's with the one of the examples of ways in which it could affect the cost.
Okay, great. Next question is, how does using Chef affect the security measures AWS already has in place?
More likely, like Chef gives us yet another option to secure the overall system state again. So although we have necessary controls or options to security options like network access control layers, security groups, so when we kind of make use of Chef, we can kind of roll out the newer security policies or enforce newer security measures in a click for either a single instance or 10 instances, 100 instances, doesn't matter. You have a holistic view of all your instances state, and the newer security functionality and newer security policy is just a recipe. Those recipes can be hand-coded using Ruby, uploaded to the Chef server, and pushed it to all the instances. So all the instances are orchestrated and brought to speed to your latest security policies. So it really depends on what exactly you're trying to do with the recipe. With security, you definitely have a real option or an easier option to push all the necessary end state in a click.
Okay, we have one more question that rolled in, and just real fast, if anyone else has a question, go ahead and type it in now. Otherwise, we'll end right after this question. Naveen, how does running Chef and CloudFormation in tandem affect the cost?
So the cost or the billing aspect of Chef isn't governed or doesn't come under the perspective of AWS as it is. So you would be billed or you would subscribe to Chef in a separate way. What exactly you run in an instance or what are the application you run inside an instance doesn't come under, or AWS doesn't care about what exactly you would like to try to do with that instance. So Chef is one particular thing. You would be paying for AWS resources based on your need and based on your consumption. And with Chef, you would try to do the same piece of work faster, quicker in a single way. So which means that Chef doesn't kind of affect anything with the cost or a cost perspective altogether. More likely, like it gives you easier control to get the real hold of your instances. So that's how we could put it. So Chef by itself doesn't kind of meddles with the cost or costing AWS instances.
Okay, great. It looks like that's all the questions that we have. I would just like to thank everyone real fast for joining us today. Thank you, Naveen, for putting that on. That was very wonderfully done. We will be following up to all of you with a link to the presentation, as well as a video link online in the next 24 hours or so. Once again, thank you for attending and have a good week. Thank you, Naveen.
Thank you, Brian. Have a nice day, everybody.